Good afternoon, everyone. I'm called Namakula Josephine from Group 2E, from Group 2 in evening class, and I'm going to go through application of Mlops concepts in our project, which is interpretable machine learning techniques for students' grade prediction. So I'm going to first take you through the introduction of Mlops, a machine learning operations, which are a set of practices that automate and simplify machine learning workflows and deployments. Machine learning and artificial intelligence are core capabilities that you can implement to solve complex real-world problems and deliver value to your customers. MLOps in an ML culture and practice that unifies ML applications development with ML system deployments and operations. We can use MLOps to automate and standardize processes across the ML lifecycle. And these processes include model development, testing, integration, release, and infrastructure development. So what are the relevance of MLOps in predicting students' performance? First one is efficient model deployment, which improves troubleshooting and model management in production. We have monitoring and maintenance. MLOps tools continuously monitor deployed models, detecting performance drift and alerting about potential users. We have scalability. MLO practices such as automated scaling of infrastructure and containerization allow our models to handle varying workloads efficiently, ensuring consistent performance even as the volume of the data increases. We have collaboration and reproducibility that is very explainable. We have experimentation and iteration, which facilitates rapid experimentation and iteration by automating workflows and providing tools for tracking experiment results, which allows us to quickly test different algorithms, features, and hyperparameters to improve the accuracy and effectiveness of our grade prediction models. So this is an ML life cycle. We have developing, we have data preparation, we have retraining, we have exploratory data analysis, we have review deployment, we also have monitor and inference. Influence of MLOps trends and techniques. We have automated pipelines, which helps to automate data collection, cleaning, and pre-processing, ensuring consistent and high-quality data for our model. We have model versioning and management. We have continuous integration and deployment, which promotes the adoption of continuous integration and continuous delivery practices in machine learning projects, enabling automated testing, validation, and deployment of models. We have scalability and resource management, which focus on optimizing resource utilization and scalability, especially in cloud environment. We have collaboration and knowledge sharing, which encourages collaboration and knowledge sharing among team members through centralized repositories, documentation, and reproducible workflows. Application of DevOps and data ops. DevOps is a culture of collaboration and automation, automation of developer and operations to continuously improve deployment and reduce friction between business units. Data ops are specific data ops. They focus on use of DevOps concepts and automation principles to manage data workloads like aggregation, transformation, storage, analysis, and many others. So we have So when we go to differentiation between heavy MLOps and heavy and light MLOps, MLOps are preferred for complex models, light data sets, and frequent updates, which requires more technical expertise and resources. We have light MLOps are suitable for simpler models, smaller data sets, and less frequent updates, which require less technical expertise and resources. So our next slide here, we have here up, it is light workflow. Here down the pink one, these are heavy workflows. And we can see that from GitHub, we can go to Google Cloud Google Cloud Build. You can also go to Platform as a Service, which is Google App Store. Here we can predict, well, or we can go to APIs or prediction services. And here down, we have data labeling in heavy MLOps, have data labeling, data drift, feature stores, explainable AI, model registry, model monitoring, prediction, experiment tracking, integration of MLOps, hierarchy of needs and maturity models. Here is our diagram. So when we go to explanation, we have continuous monitoring. We have in DevOps, we have continuous monitoring, automated remediation, scalability, and reliability. In data ops, we have data versioning, automated data pipelines, and collaborative data practices. So if we go here to our pyramid, it runs from down up to top. Yeah. So platform, when we go to platform automation, we have feature stores, we have model serving, we have experiment tracking, there is data drift detection, there's in MLOps, we have forecasting, problem framing, prediction. How can we handle data poisoning? So data poisoning is the malicious manipulation or injection of data with the intent to corrupt the machine learning model's training process or degrade its performance. So data poisoning, we can handle it through data quality control, data validation, robust model training technique, model monitoring, secure data sources, regular updates, and retraining. So these are some of the data poisoning threats we have. So when we go to how to handle data drift, what is data drift? Data drift refers to the phenomenon where the statistical properties of the input data change over time, leading to a decrease in model performance. So we can handle it through implementing continuous monitoring of input data distribution, setting up automated alerts to flag instances of data drift, retraining machine learning models periodically, employing techniques such as domain adaptation to transfer knowledge from old to new data distributions. This is Here is the picture of the data drift problems. As you can see, naughty child constantly feeding container with new balls. Every new ball pulled doesn't reflect actual distribution. Every new ball pulled gives more information about frequency of red-black balls. So how can we handle operationalizing microservices? What are operationalizing microservices? These services involve deploying, managing, scaling independently deployable services that encapsulates specific functionalities of an application. So in the context of predicting students' grades, operationalizing microservices could involve breaking down the prediction pipeline into smaller microservices such as data processing, model inference, and result aggregation, each deployed and managed data independently. We can also have well-defined tasks implementing robust communication protocols between microservices, containerization technologies such as Docker for packaging, deployment, leveraging orchestration tools such as Kubernetes for managing and scaling microservices. We have deployments dynamically. This is the sample of the picture of the microservices. You can see from Git, you can go small reusable code, command line interface, library, microservice, service, container, as we can see. So when you go to differences between continuous integration and continuous delivery, continuous integration involves regular automated testing and validation of incrementally built software. Continuous delivery, it focuses on automatically releasing updates to environments like production. These are some of the other differences between continuous integration and continuous delivery. So when you go to feature stores, the feature store is a centralized repository that stores created features for machine model training, as we saw in our video. It helps to manage data for model creation, storage, and delivery while preventing drift. What is the importance of specific file in a Python problem? Specific file in a Python problem, such as requirement.txt, README, and configuration files, config YAML, Docker file, play crucial roles in project management, dependency management, documentation, and reproducibility. This is how helpful each file is helpful in this context. So how is it important in our students' project prediction? So this file ensure that the project dependencies are correctly managed, the project is well documented, and configuration are standardized, which facilitates collaboration, reproducibility, and maintainability of the students' grade prediction system. So with specific files, you can streamline development workflows, improve collaboration, ensure reproducibility, and maintain the quality and reliability of the students' grade prediction systems. Thank you, sir.